Remember that we motivated the concept of expectation as a way to compress the information about the distribution of a random variable into a single number. But of course, when we compress things, there's generally information that's lost. Suppose, for example, that I ask you to consider two different stocks that have the exact same expected return. Now, are these stocks exactly the same investment? Hopefully you say not necessarily. And one important aspect that's not characterized in expectation is variance. Let me show you the PMFs, or the distributions of these stocks. So stock A on the left is distributed with a center at 1, corresponding to 1% expected return. And stock B also is centered at 1 with 1% expected return. But there's an important difference here. Stock A is much riskier than stock B. And you can see this by looking at the left, that there's a lot higher probability mass that falls below 0. So for stock A, there's a higher chance that you'll lose on your investment as compared to stock B. And this intuition is captured by variance. Variance measures the spread of a distribution. And so stock A here has higher variance than stock B. It's spread out more from its average, from its expectation. And high variance, especially in the finance world, generally means high risk. Now again, for variance I'm going to show a general formula, and it's quite mathematical here, but we'll go through an example so that you can understand what's going on. So the variance of x, again, is a sum over a bunch of things, where first we have the probability of x taking on different values. And second, you can just think of this as a measure of how far from the mean. So, for example, if my mean is 6 and one of the values is 20, then the second term is going to be large. If my mean is 6 and the value is 7, then it's going to be small. So the farther out from the mean the values are, the bigger the variance and the bigger the spread. Standard deviation is also useful. It's often more useful because of its units. And this measures the same spread. You just, in different units, you take the square root of the variance. So let's do an example. Let's go back one more time to the morning commute. What's the variance of the minutes that I am late to work? So I have written in small text up here the formula for the variance, and we'll see how this works in this example. So for each value, I take the value 0 minus the mean, which you remember we calculated as 6.75 minutes in a previous video, and I'll square it. And do the same thing for the other values, 15 and 30. Now, just like we did for expectation, I need to multiply each of these things by their probabilities, 0.6 and 0.35 and 0.05. Finally, again, similar to expectation, I sum these up and get a total of 78.2. Now, by itself, this is a little hard to interpret, but just know that this has a smaller spread, a smaller variance than, say, if it had been 100, but obviously greater than if it had been 50. And we can calculate the standard deviation as well. We can just take the square root of 78.2 to get 8.8. And so just as a review, while expectation calculates the center, one measure of center of a distribution, the variance measures the spread, or how wide a distribution is.